Right, so this lesson, we are looking to Pure 2, Chapter 11. We're going to continue with the integration where previously we were working on a few things. One, we were working on standard results, where we looked at simple results where we use a formula booklet. Okay, so these formula booklet are in page 6 and page 7 of your formula booklet. We're going to use it when it comes to trigonometry terms, expressions, sec squared, cosec, cot, cosec squared, sec x tan x. But sometimes the formula booklet doesn't give you everything, does it? Then we have to rely on the number one big rule in integration, which is known as the reverse chain rule. Okay, and we look at the simpler ones with reverse chain rule, where well, if you struggle with these, and I call it simple, yes, these are the simpler reverse chain rule, because this becomes what it becomes difficult now, becomes the basic, and that's how steep the integration the whole lesson is. Right, steep gradient integration, unintended, no, right. Next one. Then we'll also look at, so rather than reverse chain rule, sometimes we need trig identities to help us. Reverse chain rule and formula booklet is not everything. Then we need the trig identities. So sine squared, we can use trig identities to help us to break it down, to make it something we can integrate. Then up to today's lesson, which is about reverse chain rule 2, where we look at a bit more complex expression where we need to use reverse chain rule, but they don't look as simple as it is. But however, reverse chain rule, it is the solution to that. So I'm not going to, well, reverse chain rule is about considering some expression. We let y to be that something, we guess the answer and we'll verify that. So that's reverse chain rule. And then at the end, after we guess the answer, we verify it, we differentiate, verify. And then at the end, we adjust and scale appropriately by matching the coefficient, right? So that's what we've done. Now, remember, in integration, there is no product rule or quotient rule. All we can do is sort of guess the answer in a way, but obviously it has to be an educational guess. Now in this one, x times x squared plus 5 cubed. Okay, now imagine I'm not asking you to integrate, I'm asking you to differentiate. Okay, ask you to differentiate. Let's cover this up. Okay, let's say we don't have the x in here. Okay, let's say we don't have the x. Okay, but I ask you to differentiate this. Now just think of on top of your head. Okay, when you differentiate inside, when you multiply them, what would you get on the outside when you differentiate this? You differentiate x squared, you get 2x. So you get an x outside, don't you? So therefore, actually, this x actually comes from differentiating this inside bracket, or this, I call it the parent function, okay? The parent function, because this is just, the child, whatever is tagging along the parent in here. This is the parent function. So we can use the reverse chain rule on the parent function, and the x itself would take care of itself. But we'll see how. Well, so power 3, if we have to use reverse chain rule, we can let y to be power of 4. Now we don't do the x outside, because the x outside comes from differentiating inside. So just believe me, okay? Trust me. Do not do the x first. Power 3, let's do one power higher, because when we differentiate power 4, we get power 3. So that's my guess answer. I need to verify that. So let's differentiate. So chain rule, take down the power. Power goes down by 1 times differentiate inside 2x. And then if you multiply, simplify a little bit, you get 8x times x squared plus 5x cubed. Does chain rule work in here? You tell me. It does. Well, why? Because you can see this term is same as that. So a note in here, on the side in here means, okay, reverse chain rule works, okay, because the algebra term is matching with the question. Now, how do you know if it's not working? I show it in here every time we work. Obviously, every time that we do it, it works, because that's a note, right? So how do you know if it doesn't work? Let's say you integrate and you get x squared in here. Let's say you got x squared, then that doesn't work, because the question only is x. What you can balance is just the coefficient. You can't balance the algebra. You can't balance variable. So, well, we'll probably get to the next lesson or the after, we'll show you some examples that reverse chain rule won't work. So in here, so what's the final answer then? The final answer is integral of x times x squared plus 5 cubed dx equals to Well, we've got an 8, which is unwanted because we only have 1 outside. So it'll be 1/8 of our guess answer, which is x squared plus 5 to the power 4, and the forgotten child plus c. Right? And that will be the answer. How do you verify it? You differentiate this, and you should get back this. All right? Next one. Okay, example, cos x sine squared x. So in this one, you said trigonometry, then you should be thinking, oh, should I use reverse chain rule? Should I use trigonometry identities? Should I use formula booklet? Well, formula booklet should always be your #1 rule to look at, but we know cos and sine squared doesn't give you anything in the formula booklet. So the second thing you want to look at is the reverse chain rule, okay? So what I want you to do is, okay, now I want you to go on the front page, and then here at the bottom, okay, I would like you to write down, just write down R in here. I'll explain later what it means, okay, R, okay? Oh, actually, RT. R stands for, I do have to explain it now, don't I? R stands for reverse chain rule. T stands for trig identities. These are your thinking steps. Okay, so the first thing you should also always consider is reverse chain rule. Obviously, if it's about formula booklet, you should go use the formula booklet straight away. Okay, but the first thing you should, otherwise, if you look at the integration, you should be thinking about reverse chain rule. Okay, and then if it doesn't work, then you think about trig identities. Now in here, oops, where was the page number we were looking on? Yeah, okay. In here, first step, we think about reverse chain rule. Well, how do we think about reverse chain rule? We see a sine squared x, so we should be thinking about sine cube x, because differentiating cube will give you square. So we'll let y, so we try reverse chain rule. I know it worked, but if it doesn't, then you use trig identities. But here, let's try reverse chain rule. That's the first thinking process using reverse chain rule for the integration. So let y to be sine x cube. Now explain to yourself, y cube. I want you to write down y cube, answer that question. Okay. Then with dy by dx. Differentiate that, it will be 3 sine x squared, differentiate inside, cos x. That will be 3 sine squared x cos x. Answer that question, y cube, because differentiating cube will give something squared, right? And that's what we need, something squared. So does it work? Well, does it work? Does our guess answer work? It works because if we check the variable terms in here, sine squared x, cos x, it's the same as the question. Therefore, it works. Therefore, it works. So therefore, the integral of cos x sine squared x dx equals to 1/3. Compare the coefficient. It's a 3 compared to 1. We don't need the 3, so it's 1/3 of our guess answer, sine cube x. Let's see. As simple as that. Simple. Yes, simple. Next one, example, one more. Example, 2x over x squared plus 1 integrate. There is no quotient rule in integration. I don't know how many times I've said this. There's no quotient rule, no product rule, okay? That's why integration, a lot of people don't hate it. So what can we do in this one? Well, reverse chain rule. How do we use reverse chain rule in here? Again, think about what differentiate will give a fraction. Okay, what differentiate will give a fraction? So if we look back at the notes in the reverse chain rule in previously in here, okay, our very first example in reverse chain rule, what differentiate give you fraction? ln, because ln denominator will give you 1 over that is the denominator. So we'll trust that and go for it. So we'll try to ln the denominator. Now, I know it will also work. That's something you should also think about, is because I know ln the denominator will work, because if I differentiate the x squared, it will give me 2x or the x on top. So I know that's how I know it will work. So I let y equals ln x squared plus 1. Okay, so y ln, because differentiating ln gives a fraction. So why do ln denominator? Because the denominator, when you differentiate ln, the 1 over whatever is inside ln bracket becomes a denominator. In this case, it's x squared plus 1. Therefore, we always ln the denominator. So let's verify it. Let's differentiate it. Differentiate ln is 1 over x squared plus 1. differentiate x squared plus 1 is 2x, which is 2x over x squared plus 1. Does it work? Well, exactly, it works. Do we have to balance anything? No at all, because once you verify it, you realize that's exactly same. Exactly same. So what's the final answer? The final answer, the integral of 2x over x squared plus 1 dx is, we don't have to balance anything. So it is exactly what we have guessed, which is ln x squared plus 1 and the child. Okay, and that's why. So what's reverse chain rule? Reverse chain rule is having an educational guess. What would the answer be when we differentiate to give rise to the integral expression? Okay, so that's reverse chain rule. We guess the answer, we verify by differentiating. If the algebra terms are exactly matching, brilliant, then you just have to, as your final answer, you just have to scale the coefficient. However, if the algebra does not the same, let's say for argument's sake, let's say I've got 2x squared in here or 2x plus 3, then I know it doesn't work because the algebra term is not matching. It's x over x squared plus 1, but this is x squared over x plus 1. Okay, right. Next one. Okay, your turn to have a go at this practice question. Okay, have a go at the question 1 first. I guess question 2 looks a bit difficult. I'll have a go at question 1. Pause the video. Have a go. When you're ready for the answer, you can press play. So the answer for that one, okay, for question 1 is that equals to a third ln x cubed plus 1 plus c. Technically, I did mention before, it's actually a bar and modulus sign in there. If you got it right, well done, move on, try the next one. If you haven't, I'll explain why. Well, we'll start off by we're letting y to be, we see a fraction, so we try to ln denominator, ln x cubed plus 1. Let's try to differentiate it. Okay, that's my guess. Let's try to differentiate. Differentiate ln is 1 over x cubed plus 1. Differentiate inside is 3x squared. So it's 3x squared over x cubed plus 1. I check the variable as the coefficients, and I realize I'm actually this x squared over x cubed plus 1. That's why it worked. You can see the algebra terms are matching, but there's no 3 in the original question. Therefore, the final answer will be a third of the guess answer plus c. Now, question 2. How do you integrate this? You might be thinking. There's no product rule. But one thing about powers of e is that no matter how we differentiate, how we integrate, we know the e itself, the whole function itself will still be there. So when you see expressions of e, what you should always try to do is you should always try to let y to be e itself, the powers of e. Okay, I'll let you have a go. Pause the video, have a go. When you're ready for the answer, you can press play. So I'll do dy by dx, differentiate. So differentiate powers of e is differentiate expressions of e, you just differentiate the power, which is differentiate x squared plus 1 is 2x. And then you have e itself in there. So is the algebra, is the reverse chain rule working? It is, because if you compare the algebra term again, exactly where it is. So the final answer, the integral of x e to the power of x squared plus 1 dx is simply a half of what I guess. I guess it to be e to the power of x squared plus 1 and then plus c. And that's the end of the practice. We've got more because we've got one very special case. Moving on, okay? Now, integrating sec to the power of nx. Sec is a very interesting function because integration, there's something different about sec. So what I want you to do is, I would like to differentiate normally, now this differentiation, not integration, differentiate normally using chain rule, differentiate from the outside to the outside, differentiate from the outside to the inside. Have a go at these 2 questions. You should be able to do it from now on. If you can't do chain rule here, then why are you on reverse chain rule? You should be going back to differentiation chain rule. Have a go at that lesson first before coming back to here. Okay, pause the video, have a go at the question. When you're ready for the answer, you can press play. So here's the answer. Okay? Differentiate sine to the power 5x, differentiate power 5 first. 5 sine x to the power 4 and then differentiate sine x is cos x. What about sec to the power 5x? Well, again, same thing. Differentiate power 5 is 5 sec to the power 4x times differentiate inside, differentiate sec x using a formula booklet is sec x 10x, which is 5 sec to the power 5x 10x. Now, what's so special about here? The special thing is in the power. Now, when we differentiate sine to the power 5x, notice the power goes down by 1. Okay, so right in here. So in here, you can see power decreases by 1. Oops. Decreases by 1. But if you look at the sec, it doesn't. Power remains the same before and after differentiation. So what's so special about sec then? What it means is when you differentiate sec or integrate sec, we know the power does not go up or go down by 1. The power just stays exactly the same. So if we have a look at the example here, integrate sec to the power 4x 10x, then we can let y to be sec to the power 4x. Normally, we let the power goes up by 1, sec to the power 5x. But we know by the example both, differentiating, integrating sec remains the same power. The power remains the same. So here I'm going to let y to be sec to the power 4x and hope it works. Finger crossed. Differentiate, okay? Differentiate. Chain rule. Power 4 means 4 sec x to the power 3. Differentiate sec x is sec x 10x, which gives you 4 sec to the power 4x 10x. You tell me, does it work? Yes, it works. So, oops. Yeah, so it works. Okay, it works. So, the final answer, integral of sec to the power 4x 10x equals to, it was a 4, now it's a quarter of what we guessed sec to the power 4x plus c. Okay, and that's it. Okay, now I'm going to show you, you can finish the lesson here, you can finish the video in here, but I'm going to also show you what happens if we let y to be sec to the power 5x, okay? Or you can try it yourself, what happens if we let y to be the, by the way, this is the wrong example, wrong answer, okay? I'm not sure if you have looked on the internet, there's something, always some funny post saying, they give you some meme in here and ask a question and then they say wrong answer only. Those posts are usually quite funny. Wrong answer only. So if we let y, okay, so let's let y to be sec to the power 5x, let's say. We see a power 4, so naturally we do power 5 because I know differentiate power 5 gives you power 4. Okay, obviously once we've learned the correct answer, we know that's not correct. But let's say in exam, you're under pressure, you do things that you do not naturally do. So what happened then? Okay, now it's important that you know what are the potential mistakes you could have made. Okay, so I'll try differentiating here. It'll be 5 sec to the power 4x, okay, times differentiate power 5 is 5 sec x to the power 4. Differentiate sec x is sec x 10x. So that equals to 5 sec 5x 10x. So we know this is incorrect. Okay, so incorrect or reverse chain rule, invalid. Okay, because the variable terms are not matching. We have a power 5 in here, we should only have power 4. And that's when you know you have to let y to be sec to power 4x. It's okay to make mistake, okay? But what you need to learn is once you make mistake, you need to quickly find out what the mistake is and rectify it. That's the hardest thing in exam when you have to do under pressure. Okay, right, and that's the end of this lesson, reverse chain rule 2.